Hi, my name is Nathaniel Albright, and I'm the Director of Respiratory, and I'm here to give you some tips on an Optiflow, which is a high-flow nasal cannula. This is our actual device, and then over on this table here, we have the circuit, the different pieces of equipment that you will need to run this, the circuit, the water, a HEPA filter, the interfaces, which are right here in different sizes, which is basically a nasal cannula. And this is a temperature probe because we want to heat the we want to humidify the gas going to the patient so it doesn't dry them out. Okay, so on the Optiflow, it's a relatively simple device. You only need an oxygen source. You do not need an air source. This device entrains air through the Bernoulli principle through the bottom. On the top here, you will see a blue button that is on and that can be off. It's just a turn off device. Okay, and what we have here is in this clear square tube, this is your flow. It goes up to 60 liters. The bottom lever runs your flow. You'll know when the flow is on because it gets very loud. So the higher the flow, the louder it gets. Now, on the knob above, it says O2. This is where you entrain your oxygen. So, clockwise turns the oxygen down, and counterclockwise turns the oxygen up. So right now, we have somebody set at 40 liters, and let's say roughly 30%. And it's all sucking in air and then blowing it out over here. So that's how the device works. We have the oxygen knob and the flow knob. And there is a shut-off valve on the side. Just runs from an oxygen, 50 PSI source, please. So the 50 PSI of the flow meter, which is the back end here, this one. In addition to all the other equipment, as an added safety precaution, we use a HEPA filter. And this HEPA filter goes in the entrainment port. So right under here, there's a hole and it fits right in. And what it does is when you entrain the air, it just, two things it does actually. It quiets the machine down a lot, it's almost like a muffler, and it filters the air that's going to the patient. In this package, the RT219, this is basically what you're gonna get. You're gonna get a short hose, a longer hose, the actual corrugated tubing that's gonna go to the patient, and you're gonna get these two valves. These are more for BiPAP, so we won't use these. We will put these to the side. There's a cascade also in there. So this just holds water to humidify to the patient. So the ones we're really gonna use, we're gonna use the longer hose, the longer corrugated tubing that goes to the patient, and the cascade. And the way we set this up is you remove, there's a tab here, you remove the tab, and now you have your cascade, which goes onto the heater. It slides right on. Just put this to the side for now. Then we are going to, as you see, the air comes out of here. So we want to feed the air from the device into the humidification chamber. So now the air is coming from here. Now we want to deliver it to the patient. It doesn't matter which hole it goes into, you can switch them. Now, you'll see that you can't see, but I'm telling you, that the air is coming off the end of the tube. And this is where the interface, or the cannula, which is right here, plugs into the tip of this device, and the person gets their high flow. So we can open one of these high flow devices. This one is a size small, upper left corner. They come in small, medium, large. We have all sizes available. There's also one for a trach that's available that we showed earlier. So this opens up, basically comes out, and you have a nasal cannula with a strap that just goes around the head. It's pretty simple. And this fits perfectly. Thing about respiratories, everything's like Legos, they always fit. So now the air is coming out of the tip of the nasal cannula. And that's how a high flow nasal cannula works. The only last point I want to make is we want to, because this is such a large amount of flow of dry air, we want to humidify to the patients because it will become very uncomfortable. So this is a heater right here. Now the heater comes, you have to plug it in. So we want to make sure it's plugged in. It's got something here we call a pigtail. And on the pigtail, all it does is just heat this wire inside of this this corrugated tubing. And you'll see that there's a port in the back, and the pigtail just fits right into the port. So that will heat it. So the last piece of the puzzle is we have to put a temperature probe, which is, it needs to be cleaned. So this is always on the machine, but the temperature probe is not always on the machine because it gets cleaned by CSPD in between uses. So our one is right over here, behind you. It's blue. This is how we connect it. As you can see, this is blue too. So the ports are color coded, and you would just plug it in. Now we have to measure the heat in two different spots. We have to measure it at the base and at the distal end. So we just would put the heated port inside here to measure, and then you'll see right at the top, we measure from up here. So just be aware, please, that if this were to pop out, you're gonna have air coming out of here. So make sure that the end of the heated wire is always in there. If you can't find a heated wire, if you're having trouble finding a heated wire, you can close this port, and you can close this port here, and you can deliver the high flow. It's just not going to have heated humidity until we find one of the heated wires. It's an option if you can't find them. Okay, but these are different spots where there might be a disconnect, and then the patient's not getting all the flow they need. You'll hear it, it'll be a pretty loud sound. It's a simple on and off switch. Right here. It turns on. It usually, I mean, it might alarm because we don't have the water in yet, but if we grab the last piece that we saw, this is just sterile water. And right off of the top, you'll see you can, with the water, you can spike the water, and we just hang it. So the water just gravity flows down into the chamber. So if we go over all of this, you have the machine. We have oxygen, we have flow. Okay, so air is being given, oxygen is being given, air is being entrained. It's coming out of here. It's going through this tube, being humidified, coming down, humidified, and being delivered to the patient. And the humidification process, all we're doing is we have a water bag that's spiked, so it's gravity-fed water into this chamber. This device right here is going to heat the water to create humidity for the patient. And right here, and at the distal end of right here, and at the distal end of the corrugated tubing, it's going to control the temperature so it doesn't get too hot.
So you don't have to control the temperature. You just turn this on. Just turn this on.
There is the one thing you can do, and people go back and forth, but this button right here, if you hold it down, if you just hold it, it'll go into either invasive, and you'll see it has a person with an ET tube in it, or non-invasive, which I have it set in. And just by holding the button, it'll switch to one of the two. And what that does is, if it's invasive, it heats the temperature up a little bit higher, about 1 or 2 degrees higher.
Okay, what are reasons this would alarm?
Reasons this would alarm is if there's an excess water in the tubing, it might alarm. Tubing needs to be drained. Sometimes the main reasons this would alarm is if the actual pigtail wasn't working, or the circuit was broken inside of the machine, or the temp probe, something was wrong, defective. Those are the main reasons. I'd expect to see this temperature in non-invasive at 32, which it's working its way up to now. Oh, and if there's no water, like we don't have water, so eventually this would start alarming because we haven't spiked the bag for water. But if it's spiked with water, it shouldn't give you any problems.
And why would you use this machine versus a vapotherm?
Why would I use this machine? Well, they do the same thing. One of the advantages of this machine is that it just runs off of oxygen. So in a room like this, where you have air and oxygen available, you could use a vapotherm, correct? And they do basically the same thing. But in a room where there's no medical air available, this is the best option because you don't need medical air because it entrains it itself.